Hello friends. So lockdown force. I think everybody must be taking precautions and staying safe and working efficiently. For my dear students, I am giving this lecture to how to find out the support reactions for different types of beams. If you see the diagram, the first beam is a cantilever beam. The second beam is a simply supported beam, and the third beam is a overhanging beam. So today we are going to take three problems for different types of beams and how to find out the support reaction. Okay, so first of all I'll start with the problem number 1, that is cantilever beam. Okay, so what is the first step for a cantilever beam? For a cantilever beam, we have to first find out the reactions, and hence we have to draw a free body diagram. What is a free body diagram? So to draw a free body diagram, we have to take all the points A, B, C and D in the vertical downward direction. Okay. Then we have to draw a horizontal line. Okay. Then this is a fixed support. So at fixed support we have got three reactions. So I'm assuming that vertical reaction VA is in upward direction, horizontal reaction HA is in horizontal direction moving towards right, and a clockwise movement ME. These all directions I'm assuming. Okay. Then at a distance of 0.5 we go to the point B, and at point B we have got a vertical load in the upward direction of magnitude 5 kilonewton. Then again at a distance of 0.5 we reach to point C, and we have got a UDL from C to D. So we know that when we have got a UDL, so UDL we try to have or convert it in terms of a point load. So UDL is 10 kilonewton. What is our formula? That if this is UDL of 10 kilonewton per meter and the length is 2 meters, so the formula is UDL multiplied by length. What is UDL? 10. What is length? 2. So 20 kilonewton is the point load. Okay. And this point load will act at the center of CD. What is the center of CD? So CD is 2 meters. So its center will be 1 meter. So at a distance of 1 meter, we have a UDL which is converted in terms of a point load 20 kilonewton at center. Okay. So this diagram is called as a free body diagram. Okay. So this is a free body diagram. Now what we will do? We will apply our three conditions of equilibrium. So first is sigma H is equal to 0, force moving in right direction positive, left direction negative. Okay, so HA is in the right direction positive and there is no another horizontal load. So HA is equal to 0. What is our second step? Sigma V is equal to 0. What is sigma V? Algebraic sum of all the vertical forces. What is the sign convention? Upward force positive, downward force negative. So VA in the upward direction positive, 5 in the upward direction positive, 20 in the downward direction negative. So that is equal to 0. So VA minus 15, that is equal to 0. So VA, that is equal to 15 kilonewtons. So second reaction, that is VA, we have calculated as 15 kilonewtons. Then step number 3, we have to find out the moment. So moment, we take it at suppose point A. So moment about point A. What is the formula for moment? Force into perpendicular distance. Okay. Distance from where? From the point where we are taking the moment. Here it is point A. So we start with first VA. The line of action is coinciding at the same point, so no moment. HA also line of action coinciding, no moment. But MA is a moment, so automatically we'll put it downwards. And it is in clockwise, so we are assuming it as positive. I forgot to mention that clockwise moment, we take it as positive, and anti-clockwise moment, we take it as negative. Okay. So MA is clockwise positive. Second is 5. So 5. And what is the line of action? So I'm extending it the downward direction. This is line of action. Okay. What is the point? A. So what is the distance up to point A? 0.5. So zip 5 into 0.5. How will it rotate? It will try to rotate in the anti-clockwise direction, so it will be minus. Then we have got the third force, that is 20. So 20, and what is the distance? So we extend the line of action. So this is LOA, and what is the distance from LOA to the point A? 1, 0.5 and 0.5, so it comes out to be 2. And how will it rotate? It will try to rotate in the clockwise direction. So clockwise is considered as positive. Okay. So MA minus 2.5 plus 40. Okay. So that is equal to 0. So MA is equal to 2.5 minus 40. So MA, that comes out to be 37.5 kilonewton into meter. Why kilonewton into meter? Because force is kilonewton, distance is meters. Okay. So now what does this negative sign indicate? So negative sign shows that the moment is in anti-clockwise direction. Okay. Now we come to the second problem, and the second problem is for a simply supported beam. So for a simply supported beam, if I want to draw a free body diagram, again I have to take the point A in the downward direction, point B in the downward direction, point C in the downward direction, and point D in the downward direction. Okay. So this is our problem number 2 for a simply supported beam, right? So we have taken all the points in the vertical downward direction and we are drawing a horizontal line. A is a roller support, so there will be one vertical reaction VA. I am assuming the direction of VA in the upward direction. Then 6 is the UDL and it is for 2 meters. So what is our formula? UDL multiplied by length. Okay. So UDL is 6 and length is 2. So 12 kilonewton will act at the center. So this is 12 kilonewton and it is acting at the center. To center will be 1 meter. So 1 meter and 1 meter. We reach to the point B. Then we come to the point C where only point load is acting at a distance of 1 meter. So we can show that this is point load of 2 kilonewton. And then we come to the point D where point D is a hinge support. So hinge support, how many reactions? 2 reactions, vertical reaction VA and horizontal reaction HD. Again, the directions are assumed. Okay. So the first step to draw the free body diagram is O. Now what we have to do? We have to apply our conditions of equilibrium. And to apply the conditions of equilibrium, the first step is sigma h is equal to 0. So there is no horizontal force acting, only Hd in the right direction, which is considered as positive and left as negative. So Hd is equal to 0 is already satisfied. Then we come to the second equation. What is our second equation? Sigma V is equal to 0, upward positive, downward negative. So VA in the upward direction positive, 12 in the downward direction negative, 2 in the downward direction negative, and VD in the upward direction positive, that is equal to 0. So VA plus VD is equal to 14 kilonewton. This is our first equation. Okay. Now we apply our third condition of equilibrium, that is sigma moment is equal to 0. Okay. What is the sign convention? Clockwise moment positive, anti-clockwise moment negative. Okay. So now we'll take moment about either of the support. We can take at A or we can take at B. So moment about point A we are taking, that is at this point. So all the forces distance will be with respect to point A, right? So first is 12 into what is the distance up to point A? 1. How it is trying to rotate? In the clockwise direction. So it will be considered as positive. Second is 2 kilonewton. What is the distance up to point A? 1, 1 and 1, that is 3 meters. Again it is trying to rotate in clockwise direction. So clockwise is positive. And last is VD. What is the distance of VD with respect to point A? 1, 2, 3 and 4. So VD into 4. As it is moving in the anti-clockwise direction, it will be minus. That is equal to 0. So we get 12 plus 6 is equal to 4 VD. Negative, if we take to the right side, it will be positive. So 18 is equal to 4 VD. So VD, that is equal to 18 divided by 4, which comes out to be 4 4s are 16 and 2, so 4.5 kilonewtons. So VD, that is equal to 4.5 kilonewtons. Okay, this is one answer. Because the reaction is VA and VD. So we have found out VD. Substitute VD in equation 1. Substitute VD in equation 1. So VA plus 4.5, that is equal to 14 kilonewtons. So VA, that is equal to 14 minus 4.5, that comes out to be 9.5 kilonewtons. So VA is equal to 9.5 kilonewtons. Okay. So what were our two support reaction in this particular problem? At point A, VA, at point D, VD and HD. So we have calculated HD, we have calculated VD and we have calculated VA. Okay. So all three support reactions we have calculated. Now we come to the third point, that is third problem, which is a overhanging beam. Okay. So for overhanging beam, the same procedure is to be followed. That is, we have to first draw a free body diagram. So to draw a free body diagram, we have to take the points A, B and C in vertical downward direction. and then we have to draw a horizontal line. Okay, at A it is a simple support, so we assume the reaction in the upward direction positive, that is VA. Okay, over here we assume positive direction, that is VB, right? And UDL. What is the formula to convert UDL in terms of point load? UDL multiplied by length. What is UDL? 5. What is length on which it is acting? 2 meter. So 5 into 2, that is 10 kilonewton. And where will it act? It will act at the center of 2. So center of 2 is 1 meter. So 5 2s are 10. So 10 kilonewton point load will act at the center. Okay, and this will be also 1 meter. Fine. And then at the free end, we have got again a point load of 10 kilonewtons. Okay. So now this diagram is a free body diagram. Now we can apply our conditions of equilibrium. So the first condition of equilibrium, that is sigma h is equal to 0, is already satisfied as there is no horizontal force acting on the system. Second is sigma v is equal to 0. What is our sign convention? Upward positive, downward negative. So VA in the upward direction positive, 10 in the downward direction negative, VB in the upward direction positive, 10 in the downward direction negative, that is equal to 0. So VA plus VB is equal to 20 kilonewtons. Okay, this is our first equation. Now we apply our third condition of equilibrium, that is sigma moment is equal to 0. Where we will take the moment? We can take the moment at point A, or we can take the moment at point C, or we can take the moment at point B, because in overhanging beams the moment is 0 at the point that is support as well as at the free end. Okay, so suppose I am taking moment about point A. So I'll write down moment about point A. What is the formula? Force into perpendicular distance. Distance with respect to which point? The point where we are taking moment. Which is the point at which we are taking moment? At point A. Okay. So, line of action of 10 is this and the point is A. So, this much is the distance, that is D. Okay. So, 10 into 1. How it is rotating? Clockwise. Okay. So, clockwise positive. Then VB. What is the distance up to point A? 1 and 1, that is 2. How is it rotating? Anti-clockwise. So, it will be minus. And the last is 10. What is the distance up to point A? 1, 2, 3. So into 3. How is it rotating? In a clockwise. So in a clockwise. So 10 minus 2 VB plus 30 is equal to 0. So 2 VB is equal to 40. So VB is equal to 20 kilonewtons. So this is the first answer that we have found for the reaction. Now substituting the value of VB In equation number 1, we get substitute VB. In equation 1, we get VA plus 20 is equal to 20. So VA, that is equal to 0. Okay, now sometimes what happens? Students get horrified that 0 can be the answer. Yes, we can have 0. Okay, so you have to just keep on following the steps and you can get all the answers correct. So I think that we have done all the 3 types of numericals, and if you try to follow the same steps for any type of numerical, you can get the answer. One more thing, if there is an inclined load, then please resolve the inclined load in horizontal and vertical direction. Thank you.